Dear students, as you know, we are still cultivating the concept of oxidation number. Let's roll further, and from there you will get idea how we'll break the mystery of the inorganic reaction by taking the concept of oxidation number. Now, and taking nitrogen atom, you know nitrogen, it is valence electron, there you will get 5 electrons. And its maximum oxidation number and minimum oxidation number you will get from its atomic structure. Its valence electron 5, maximum it can polarize 3 number of electron towards its nucleus. That's why minimum oxidation number minus 3 electron acceptor. Maximum 5 electron in the valence shell of nitrogen that can donate to other, that is plus 5 O. This is the maximum oxidation state or number of nitrogen. This is the minimum oxidation state or number of nitrogen in compound. Now see, oxidation number of nitrogen in any compound in between minus 3 and plus 5. I am taking example ammonia. You know in ammonia, the oxidation number of nitrogen is minus 3, which is minimum. And plus 5 will get in nitrate salt, NO3 minus, any nitrate salt, there you will get plus 5. Since you know oxygen, all oxygens are with minus 2. If you do calculate by taking nitrogen is x minus 6 is equal to minus 1, there x is equal to plus 5. And also HNO3, that is also nitrogen in plus 5. And in between oxidation states, so many compounds you will get, like in hydrogen, nitrogen, you will get in minus 2. You will, in nitrogen molecule, by nitrogen molecule, there you will get 0, NO plus 2, N2O plus 1, N2O3 plus 3, NO2 plus 4, and this is the maximum plus 5. Now, from this oxidation number, what idea you will get that I am going to discuss? See, is ammonia. You know, right? We will discuss inorganic chemistry, P block group 15, there we get nitrogen and nitrogenous compound is a part of your syllabus. Apparently, you can take inorganic is nothing but maybe you have to memorize all reactions. But remember, there is a concept, there is a logic. And a part of logic, you will get the oxidation numbers. You know, this is ammonia, minus 3. Ammonia has 3 different characters. By the way, we'll discuss ammonia. There you will get 3 different chemical characteristics of ammonia. You know, it is a pungent smell. And there you get lone pair on nitrogen in ammonia. And due to that lone pair, it is a Lewis base or base, you can say. That means you will get some reaction where ammonia will show its basic character. For example, ammonia reacts with HCl or H2SO4 to give salt. Ammonia in water, that is ammonium hydroxide, slightly alkaline, weak base. This ammonia has the characteristics like base, and you will get some reactions where ammonia acts as base. That idea keep in your mind. Another, if ammonia participating redox reaction, that part is a part of today's class, or you will get idea from the oxidation number. If ammonia participate in redox reaction, you know minus 3 is the least oxidation number of nitrogen. That means in ammonia, nitrogen with minus 3 oxidation state, that is the minimum. Never it can decrease further. Now in any redox reaction, this minus 3 oxidation number of nitrogen only can increase. That means in any redox reaction, ammonia will oxidize itself. Ammonia can oxidize to nitrogen, molecular nitrogen, or N2O or NO2, anything. But ammonia, nitrogen will oxidize. Since minus 3 is the minimum, it can increase its oxidation number. No question of decrease. You know, anyone if oxidize, then someone reduce parallelly. Ammonia, then reducing agent. You know the characteristics of reducing agent itself oxidizes, and other one will reduces. That means in any redox reaction, ammonia characteristics is a reducing agent. That you have to keep in your mind. Another characteristics of ammonia, that is the different part that you will get in complex or coordination compound. Ammonia is a good ligand. Good complexy ligand, since it has lone pair, and that lone pair donate to transition metal ion to form a coordinate bond. That means ammonia participate in three different reaction or characteristics. One is where ammonia acts as base. Another one, ammonia may participate in redox reaction where ammonia always reducing agent. And another property of ammonia that it may form complex with transition or inner transition metal ion. Similarly, see, nitrate or HNO3, this is the maximum oxidation number of nitrogen. You know HNO3, it is acid. But you know, its major characteristics, it is an oxidizing agent. Concentrated HNO3, even dilute HNO3 acts as oxidizing agent. Why? Since it is the highest oxidation state, in any redox reaction, nitrogen oxidation number only may decrease, never decrease. That means it sub-reduces. That reduces to maybe NO2, maybe NO, that does not matter, but reduces. It self-reduces, that means it is an oxidizing agent. So if you study the chemical characteristics of nitric acid or nitric salt in acid media, it will show oxidizing agent. You know HNO3 is a powerful oxidizing agent. A+5 oxidation state. It is a strong tendency to accept electron. It is a strong tendency of reduction. Strong oxidizing agent. Well, if I have oxidation number, you got idea HNO3 oxidant, ammonia reduct. If I have intermediate oxidation state like NO2 here +4 oxidation. You know, this +4 may increase to +5, may decrease to 0 or -3. That means it may act as both oxidizing agent and reducing agent. It is oxidant. Only. This is reducing agent or reductant only. Reductant only. But it is both. It will act on both oxidizing agent as well as reducing agent. Since any reaction, nitrogen +4 of NO2 may decrease to 0 or -3 or may increase to +5. That's why sometimes in intermediate oxidation state may undergo disproportion reaction. You know, disproportion reaction are those reactions where an atom of a molecule parallelly oxidizes as well as reduces. This disproportion characteristics due to the intermediate oxidation state of the atom in compound. You can tell an example. You know NO2 reacts with water, that reaction you will get in the industrial preparation of nitric acid. Industrial preparation of like Oswald method. There is the last step was NO2 absorbed in water, and NO2 there will undergo disproportion reaction to form HNO3 +5 and reduces to NO6. Here simultaneous oxidation, this is oxidation, and parallelly it will reduces to NO, that is reduction. That means due to intermediate oxidation state, it will undergo disproportion reaction. Parallelly oxidizes and reduces. That means from oxidation number, you will get idea whether the molecule acts as only reducing agent or both or reducing agent or oxidizing agent. I am taking another example. See, sulfur. You know the valence electron of sulfur is 6. It can accept maximum 2 electrons to get out it. And that's why its minimum oxidation number is -2. Maximum 6 electron can polarize with other, that is +6. So -2 H2S or any sulfide example, +6 is H2SO4, or sulfate 2-. Similarly, like ammonia, it will act as reducing agent only in any redox reaction. In any redox reaction, H2SO4 or sulfate in acid media may act as oxidizing agent. You know H2SO4 has acidic character, parallelly it has oxidizing character. But remember, only concentrated H2SO would act as oxidizing agent. Since you know here sulfur with +6 oxidation state, there was nitrogen with +5 oxidation state. Nitrogen is the element of period 2, which is much more smaller in size and much stronger electron attractive power than sulfur, comparatively bulky size. That's why electron attraction part slightly less. That's why only concentrated H2SO acts as oxidizing agent. And the intermediate, like neutral sulfur, it will undergo zero, it may oxidize or reduce, it may undergo disproportion reaction, thiosulfate or SO2 plus 4, these are the intermediate oxidation state. So many sulfur compounds you will get where the oxidation number of sulfur in between -2 and +6. Never it is greater than +6, never it is less than -2. So from there you will get a surface level idea, a preliminary idea whether it will act as oxidizing agent or reducing agent or both. SO2 acts as both here. Now see another example. I am taking KMnO, potassium permanganate, very useful oxidizing agent or reagent in chemistry with respect to our syllabus, not only with respect to our syllabus. In chemistry, it is a very good oxidant, oxidizing agent. In ionic form, we can write it is MnO4 minus. And if you do calculate the oxidation number of manganese here, you will get +7. Plus back to the electronic configuration of manganese. What you will get? Argon 3 divine 4s2. The maximum Helix electron cell. This is the maximum oxidation state of manganese. Maximum oxidation state of manganese. In any reaction, the manganese oxidation state of MnO4 minus only reduces, only decreases. That means itself always reduces in redox reaction. Always it will act as oxidizing agent. And you know we have in our syllabus, you will get so many reactions where MnO4 minus will act as very good oxidizing agent. You know MnO4 minus is acid media. When the medium is acidic, this MnO4 minus, if the medium is acidic, then it will reduces to Mn2 plus species. It's a reduces. Very good oxidizing method. But in alkali media or neutral, feebly alkaline or neutral media, feebly alkali or neutral media, it will reduces to MnO2 where the oxidation state is +4. Here also itself reduces, that means oxidizing agent. Here +7 to +2, 5 electron transfer or 5 electron, you have to add there, 5 electron acceptor. You have +7 to +4, 3 electron transposition. And you know when the medium is strongly alkali, that is pH greater than 12. Greater than 12 means strongly alkaline. Remember this one. When pH greater than 12, it will reduce us to manganate ion MnO4 2 minus, which is green color. You know MnO4 minus purple color, it is green color. Here +6 oxidation state. That means in all media, in all redox space, it will reduces. It's a good oxidizing. And intermediate oxidation state of compound like MnO2, MnO4 minus, part this MnO4 2 minus is a green color, and it will undergo disproportion reaction readily in acid media. Only in alkaline media, but it is where pH greater than 12, MnO4 minus not exist, MnO4 2 minus will exist. The from the oxidation number, you got idea why MnO4 minus is a very good oxidizing agent, and we'll use in the ORC practical chemistry. In class 12, there you will get it out. There you have redox titration. It is a secondary standard solution KMnO4. That secondary standard solution you have to titrate by standard solution, oxalic acid solution, and that is a redox mix. Another oxidizing agent that we have in our syllabus, that is dichromate, Cr2O7 2 minus. And here the oxidation state of chromium is +6. And now go back, flash back to the electronic configuration of chromium. O3d5 4s1 is the downstreet electronic configuration. That means it has 6 electrons in its valence shell and a maximum oxidation number of bromia plus 6. And in any redox reaction, it can reduce it. And this dichromate only acts as oxidizing agent. That is different measure. Not like MnO4 minus in different medium, it will act as oxidizing agent. But here, Cr2SO2 minus only acts as oxidizing agent in acid medium, remember, and it will reduces to green Cr3 plus. Only acts as oxidizing agent. You got idea of which one oxidizing, which one reducing agent from the oxidation number. Now, I'll go to give another example. Students can think inorganic is a boring part, but remember, all reactions in inorganic chemistry, there's an important logic. And to get that logic, to digest that logic, you have to take idea of oxidation number preliminary, reduction potential, oxidation potential idea, as well as the acidic strength idea. If you have these ideas, then you can define how this reaction will occur, how reaction occurs in the forward direction, why this product will form in the reaction. Remember this. One of the part is oxidation number. PbO2. PbO2. Here the oxidation number of lead is +4. Lead is the group 14 element with a carboxylicon germanium P lead. If you have idea about the inert pair effect is the down the group, inertness of the s electron increases. Lead, there you get 6s2, 6p2 electronic configuration. And due to heavy nucleus, you go high effective nuclear charge. Lead 82, out of 82 electrons, so many electrons in it, you will get in D subcell, H subcell. D, A, and H subcells, poor shielding effect. And due to poor shielding effect, effective nuclear charge is very high. And the S electrons is highly inert with respect to formation of bond or with respect to the formation of ion. And if you remember, here lead is +4 oxidation state, but the stable oxidation state of lead due to inert pair effect, stable oxidation state of lead state of Pb is +2. Due to inert pair effect, the reason is inert pair effect. 6s2 highly inert, since lead nucleus, which has high effective nuclear charge, it will tightly bounded the 6s electrons. P electron participative bonding. It may be ionic bond or covalent. PbO2, that's why +4 state highly unstable. Remember, that's why it is abnormally powerful oxidizing agent. It is an abnormally powerful oxidizing agent. Abnormally powerful oxidizing agent. Oxidizing agent. Well, I've written here abnormally powerful. Read in your mind. This is abnormally powerful oxidizing agent. See, MnO4 minus good oxidizing agent in acid media. Itself reduces to Mn2+. It is so powerful oxidizing agent. Even it will oxidize manganese salt to MnO4 minus in acid media. Think about this. So powerful oxidizing agent due to inert pair effect. It's a stable state is +2. The when it will show its oxidizing character, otherwise it will reduces to +2 lead compound. Now what reaction came in JE advanced? The PbO2 plus HNO3. The question was, what gaseous product we will get in this reaction? See, how I will predict the gaseous product or the oxidation number helps to predict what gaseous product you will get from this reaction. See, I told you it is a abnormally powerful oxidizing agent. It will oxidize someone which atom we oxidize in this reaction. Here say oxygen with -2, hydrogen with +1, nitrogen with +5, oxygen -2 oxidation state. No question of further oxidation of H +1. 6, hydrogen, highest oxidation state +1. No question of further oxidation of nitrogen, since it is the highest oxidation state +5. Only oxygen can oxidize. Since it is a very powerful oxidizing agent, keep in your mind, it is powerful oxidizing agent. It will oxidize someone. So why will oxidize in this reaction? One and only option, oxidant can oxidize here. And if oxidant will oxidize, one and only gaseous could become of this reaction, there is oxygen. Without knowledge of this reaction, you can predict what product herefore. That idea only can give oxidation. Now, my last example of this part of video. A question came in very advanced. IO4 minus plus H2O. I don't know what is the product, but I can predict the reaction. There was 4 options. It is oxidizing, it is oxidizing, it is reducing, it is oxidizing. But when there's a combination, there was 4 options. How you predict this? The oxidation number will give idea. See, the oxidation state of iodine here +7 in IO4 minus, which is the highest oxidation state of any halogen. Since halogens have 7 electrons in their halide cell. Here is 2O2 -1, peroxide. And oxygen -1 is the intermediate oxidation state of oxygen. It can oxidize to 0, it can reduce to H2O or O2 minus. That means H2O2 can act as oxidizing agent as well as reducing agent. It has dual character. But IO4 minus, since iodine with highest oxidation state, only it can reduce, only it can act as oxidizing agent. That means with the knowledge of oxidation number, you can predict IO4 minus always oxidizing agent. Always. If it is oxidizing agent, then it must be reducing agent. That means you have predicted very clear picture you got from the oxidation number idea. By this way, any reaction, I'm not telling you everything is oxidation number, but oxidation number will give a preliminary idea of inorganic redox reaction as well as organic redox reaction. Thank you, my students. Please wait for the next class. We'll discuss further by getting the oxidation number. We'll give idea about the equivalent weight. See, the most important part of the stoichiometry, that is the equivalent weight. Thank you to